All right, welcome. In this explainer, we're going to break down the core technical requirements for getting an SAP HANA system up and running. We'll walk through the essential decisions you're going to face when you're building out this powerful and, just as importantly, reliable platform. So here's our game plan. We'll cover how to size your system, where it's going to live, how to keep it running 24/7, and how to manage it for the long haul. And it all starts with your first big decision. Okay, first things first, scaling your system. This is probably the most fundamental decision you'll make. It all boils down to one question. How are you going to provide the raw processing power and storage capacity that your business needs? Your first strategy is what we call scale up. The best way to think of this is like upgrading a single powerful computer, but on a massive scale. You take one physical machine and you just beef it up. You add more RAM, more CPUs, all within that single box. And we're talking about some serious power here. The largest supported appliances can go all the way up to 24 terabytes of RAM. Now, the alternative is to scale out. So instead of having one gigantic machine, you take multiple independent servers, we call them nodes, and you link them together so they act as one big distributed system. This is great because it lets you spread the workload across many machines and get around the physical limitations of a single piece of hardware. So that's the choice. Do you make one machine incredibly powerful, or do you distribute the load across a whole cluster of them? There's no single right answer here. It really depends on what kind of work you're doing and, how you expect your data needs to grow over time. Okay, so once you know how you're going to scale, the next logical question is, well, where is this system actually going to live? You've got two main paths you can take. First is on-premise. This means you install SAP HANA right in your own data center. You have maximum control. The other option, of course, is a cloud deployment. This is often way faster to get going and usually has a lower operational overhead because the cloud provider is managing all that underlying infrastructure for you. Now, if you do go the on-premise route, you have another decision to make. You can buy a pre-configured appliance from a hardware vendor. It's all set up and ready to go. Or you can use the tailored data center integration approach. We just call it TDI. This gives you a lot more flexibility to use your own certified hardware that you might already have. But here's the thing, no matter which deployment choice you make, the foundation is really consistent. SAP HANA runs on certified hardware from either Intel or IBM power systems, and the operating system is always going to be a supported Linux distribution, either SUSE or Red Hat. All right, we've decided on the scale and the location of our system. Now let's talk about one of the most critical factors for any serious application. How do you protect it from downtime? How do you keep it running?
Let's start with something simple, like a power failure. You might worry because HANA is an in-memory database, but it has a fantastic built-in recovery process. See, it automatically saves a snapshot of memory, called a save point, to disk every 5 minutes. It also logs every single transaction. So when the power comes back on, it just reloads that last save point, replays the transaction log, and you're right back to a consistent state with no data loss. It's pretty slick.
But what if it's not just the power? What if an entire server fails? Well, for that, we have high availability. In a scale-out system, you can have what's called a warm standby server, just waiting in the wings. If an active server goes down, the standby server can automatically and very quickly take over its job with almost no disruption. And then there's the worst-case scenario. Your entire data center has an outage. For this, you need disaster tolerance. This is achieved through system replication. Your main system is continuously syncing all its data in real time to a secondary system in a completely different location. So if the worst happens, your business can fail over to the other site and just keep on running. Okay, moving on. A successful implementation is about so much more than just the initial setup. You have to plan for the long term. You need a clear strategy for managing the system over its entire life cycle. System management is really split into two key areas. First, there's platform lifecycle management, or platform LCM. This is all about the core system software itself, the installation, the updates, the configuration. Then there's application LCM. This focuses on managing the stuff running on the platform. You know, your data models, reports, and all that content. SAP actually makes this whole process pretty predictable. They release a new major version called a Support Package Stack, or SPS, once a year. And get this, once you're on a specific SPS, they'll support it with bug fixes and security patches for 2 full years. This creates a really stable and manageable schedule for planning your updates. So, let's bring all these pieces together. We've gone through the crucial technical decisions you'll need to make, and all of them are going to contribute to your final implementation blueprint. As we've seen, a well-designed SAP HANA system really balances these 4 key things. It starts with the right scaling strategy, scale up or scale out. It's built on the best deployment model for your company, on-premise or in the cloud. It is absolutely protected by robust plans for high availability and disaster tolerance. And finally, it's all supported by a clear strategy for managing its lifecycle. Getting these technical decisions right from the start is absolutely critical. It ensures your system won't just perform well today, but that it's going to stay scalable, resilient, and manageable for years to come. Which, of course, leads to the one essential question you should be asking your team.